Galvanization is the process of applying a protective zinc coating to steel or iron, to prevent rusting. The most common method is hot-dip galvanization, in which parts are submerged in a bath of molten zinc. Galvanizing protects in two ways: it forms a coating of corrosion-resistant zinc which prevents corrosive substances from reaching the more delicate metal. The zinc serves as a sacrificial anode so that even if the coating is scratched, the exposed steel will still be protected by the remaining zinc. History and etymology: the term is derived via French from the name of Italian scientist Luigi Galvani. Originally, galvanization was the administration of electric shocks, in the 19th century also termed Faradism. This sense is the origin of the meaning of the metaphorical galvanize into action, referring to suddenly stimulating a complacent person or group to take action. The term galvanization has largely come to be associated with zinc coatings, to the exclusion of other metals. Galvanic paint, a precursor to hot-dip galvanization, was patented by Stanislas Sorel, of Paris, France in December, 1837. The earliest known example of galvanizing of iron is found on 17th-century Indian armor in the Royal Armouries Museum collection. Methods: hot-dip galvanizing deposits a thick robust layer that may be excessive. In the case of automobile bodies, where additional rust-proofing paint will be applied, a thinner form of galvanizing is applied by electrogalvanization. The hot-dip process does generally not reduce strength on a measurable scale, with the exception of high-strength steels where hydrogen embrittlement can become a problem. This is a consideration for the manufacture of wire rope and other highly stressed products. The protection provided by hot-dip galvanizing is insufficient for products that will be constantly exposed to corrosive materials such as salt water. For these applications, more expensive stainless steel is preferred. Some nails made today are electrogalvanized. Nonetheless, electroplating is used on its own for many outdoor applications because it is cheaper than hot-dip zinc coating and looks good when new. Another reason not to use hot-dip zinc coating is that for bolts and nuts size M10 or smaller, the thick hot-dipped coating fills in too much of the threads, which reduces strength. This means that for cars, bicycles and many other light mechanical products, the alternative to electroplating bolts and nuts is not hot-dip zinc coating but making the bolts and nuts from stainless steel. The size of crystallites in galvanized coatings is a visible and aesthetic feature, known as spangle. By varying the number of particles added for heterogeneous nucleation and the rate of cooling in a hot-dip process, the spangle can be adjusted from an apparently uniform surface to grains several centimeters wide. Visible crystallites are rare in other engineering materials. Thermal diffusion galvanizing, a form of sheridizing, provides a zinc coating on iron or copper-based materials partially similar to hot-dip galvanizing, but the final surface that results is different in that all of the zinc is alloyed. Zinc is applied in a powder form with accelerator chemicals. The parts and the zinc powder are tumbled in a sealed drum while it is heated to slightly below zinc's melting temperature. The drum must be heated evenly, or complications will arise. Due to the chemicals added to the zinc powder, the zinc iron makes an alloy at a lower temperature than hot-dip galvanizing. This process requires generally fewer preparatory cleanings than other methods. The dull gray crystal structure formed by the process bonds more strongly with paint, powder coating, and rubber overmolding processes than other methods. It is a preferred method for coating small, complex-shaped metals, and for smoothing and rough surfaces on items formed with powder metal. Eventual corrosion. Although galvanizing will inhibit attack of the underlying steel, rusting will be inevitable, especially if exposed to the natural acidity of rain. For example, corrugated iron sheet roofing will start to degrade within a few years despite the protective action of the zinc coating. Marine and salty environments also lower the lifetime of galvanized iron because the high electrical conductivity of seawater increases the rate of corrosion primarily through converting the solid zinc to soluble zinc chloride which simply washes away. Galvanized car frames exemplify this. They corrode much quicker in cold environments due to road salt. Galvanized steel can last for many years if other means are maintained, such as paint coatings and additional sacrificial anodes. The rate of corrosion in non-salty environments is mainly due to levels of sulfur dioxide in the air. Galvanized piping. In the early 20th century, galvanized piping replaced cast iron and lead in cold water plumbing. Typically, galvanized piping rusts from the inside out, building up plaques on the inside of the piping, causing both water pressure problems and eventual pipe failure. These plaques can flake off, leading to visible impurities in water and a slight metallic taste. The life expectancy of such piping is about 70 years, but it may vary by region due to impurities in the water supply and the proximity of electrical grids for which interior piping acts as a pathway. Pipe longevity also depends on the thickness of zinc in the original galvanization, which ranges on a scale from G40 to G210, and whether the pipe was galvanized on both the inside and outside, or just the outside. Since World War II, copper and plastic piping have replaced galvanized piping for interior drinking water service, but galvanized steel pipes are still used in outdoor applications requiring steel's superior mechanical strength. This lends some truth to the urban myth that water purity in outdoor water faucets is low, but the actual impurities are harmless. This is not always the case in pre-1986 copper pipe where lead-containing solder was commonly used. In installations where copper pipe has been fitted to replace a section of corroded galvanized pipe, a dielectric fitting, usually a union, must be used to join the two types of pipes. Otherwise, the presence of water in contact with differing metals creates an electrical current that can cause galvanic corrosion. In some amateur installations, the failure to use this special fitting has caused the lead in the solder to leach into the drinking water. A common location where this occurs is where a home's copper piping connects to a galvanized steel municipal supply line. The presence of galvanized piping detracts from the appraised value of housing stock because piping can fail, increasing the risk of water damage. Galvanized piping will eventually need to be replaced if housing stock is to outlast a 50 to 70-year life expectancy, and some jurisdictions require galvanized piping to be replaced before sale. One option to extend the life expectancy of existing galvanized piping is to line it with an epoxy resin. See also. References. External links: American Galvanizers Association.